Hello everyone, today we're discussing titanium joint replacements using the alloy titanium 6 aluminum 4 vanadium, otherwise known as Ti-6-4.
The first total joint replacement was performed by Themistocles Gluck in 1890. In 1891, Gluck performed an ivory ball and socket joint that he fixed to bone with nickel-plated screws. Subsequently, he experimented with a mixture of plaster of Paris and pumice with resin to fix the joint in place. He also replaced a 17-year-old girl's knee with an ivory prosthesis. Most of the joint replacements he performed failed due to infection developing inside the patient's body. Sir John Charnley was successful in completing the first partial hip replacements that modern artificial hips are based on today. Tons of materials were tested for prosthesis, such as rubber, glass, acrylic, and Vitalium, which is an alloy of cobalt, chromium, and other metals. One of the most important of these materials is Ti-6-4, which we will discuss in detail later.
Looking at this picture, you can see the mechanics of the object and the basic overview of how a total hip replacement procedure is done. After the initial incision, the surgeon removes the femoral head of the ball and socket joint making up the hip and replaces it with a prosthetic ball made up of Ti-6-4 to fit the socket of the hip joint. The plastic capsule is then placed inside the acetabulum of the pelvis to fit the ball to make the joint. The two pieces are then connected and the patient is stitched up, and soon they will be back to walking.
This is an electron microscope image of Ti-64 alloy production using additive manufacturing. The photo on the left shows a fracture of the alloy. The photo on the right shows pores that build up during the additive manufacturing process.
Turning to the composition of the object, prosthetic joints are primarily made up of both titanium or cobalt chromium alloys and polyethylene plastics. A ceramic/metal mixture is also used to make artificial joints. All of the materials that are placed inside of the body must be biocompatible. This means that it is safe for the body will not reject the material, or the joint does not cause an infection to the body.
Ti-6-4 is found in many objects that are used in daily life, such as gas turbines, parts used in making the Boeing 787 aircraft, and dental implants. Today, titanium is used as the leading metal in prosthetic joint production.
Titanium was first discovered in 1791 by Reverend William Gregor when he found black magnetic sand. 4 years later, Martin Klaproth took the magnetic metal and called it titanium. Pure titanium is not found anywhere on Earth, but rather it is found in compounds in the Earth's crust. In order to produce Ti-6-4 alloy, you begin with the two starting material powders, usually titanium oxide and aluminum. You mix the powders and heat them in an inert atmosphere using argon gas. This mixture is then separated, purified, and then the powder can be used in various manufacturing processing techniques like forging, extrusion, and metal injection molding.
One of Ti-6-4's most common uses are for joint replacements in medicine. It's extremely biocompatible, and it has many uses in marine and chemical industries.
2 million pounds of titanium are produced annually for the Department of Defense, and in 2006 it was used for 73% of aerospace production in the US. Though Ti-6-4 is widely used, it is hard to extract titanium, so it is fairly expensive. Because of this, products containing Ti-6-4 are quite expensive as well.
This graph shows just how expensive joint replacements can be. In the red states, joint replacements cost more than the median annual income. In the blue, they cost less than the median annual income for the state. As you can tell, these are very expensive procedures that require large sums of money.
Some special characteristics about titanium include its uses in marine, industrial, and chemical processes. It is very strong but lightweight, and it's biocompatible, which means it doesn't get rejected by the human body.